It's really exciting for me to introduce Jennifer Bay Williams. If you're a math educator, I'm sure you're familiar with Jennifer's work in fluency and everything else she does. She is, I'm going to say, probably an understatement, a passionate mathematics educator. She's teaching at the University of Louisville. She's written several books. And I do want to mention the book that just came out called Figuring Out Fluency, which I believe we're going to be seeing some examples from tonight, that she co-wrote with John Sangiovanni. And at least in my mind, John and Jennifer together on fluency, that's a pretty dynamic duo when it comes to fluency. So I am going to wrap up what you're going to see and hear tonight. And the word is amazing. And if you don't feel at the end that this has been amazing, then just, you can prove me wrong. But with that, I'm going to welcome Jennifer, and off you go, Jennifer.
We'll have a makeup session. Thank you, Mark. That was a very thoughtful introduction. I appreciate it. And I do have a book just out on figuring out fluency, but the title is really about exactly as it says. Figuring out fluency is very important. It actually has a lot to do with how our students feel about themselves as mathematicians and how they feel about themselves as human beings. And so that's where my passion for fluency has come from, is trying to really change from a traditional classroom where students are just memorizing rotely how to do things to feeling like they own the math, that they can themselves come up with ways to solve problems, and they are on the lookout for good methods to solve computation. So that's what our session is about tonight. Briefly, I just want to make sure we're all on the same page with what is fluency. And then we're going to explore significant strategies. And we're going to do that by actually just going to Braining Camp and solving tasks. We're going to be posting some of our tasks in Google Docs. And so we're going to be just doing lots of computation and reasoning. And then we're going to come back and debrief from that at the end. That's my hope. I tend to be overplanned. So this is just a kickoff for us. I want to start with thinking about what fluency is. And in our book, we talk about 12 different fallacies that really stand in the way of developing mathematically proficient students. And tonight, I just want to address 3 of them, because those 3 are critical to tonight's session. So the first is that fluency is about basic facts. And if you type in Google search something like basic facts, or if you go to Amazon and type in, fluency, then what's going to pop up is just tons of stuff on basic facts. So fluency is not just about basic facts. We talked about basic fact fluency last week. So part of the trouble is that fluency is limited to basic facts. Part of the thing is it doesn't even get at fluency with basic facts. The fluency with basic facts is making sure students not only get their facts down, but that they also know strategies like the making 10 strategy, the pretend to 10 or compensation strategy, and near doubles. These are the strategies that become part of being fluent with your facts. And with multiplication, the parallels are that students are able to double. If they know 2 times a number, they can double that answer to get 4 times the number. They could break a number apart in order to add a group, or break it apart to subtract a group. And that these strategies learned with the basic facts grow into strategies that are useful for all kinds of numbers. And that's what we're doing tonight. We're focusing on growing fluency out from basic fact fluency. We have these good beginnings because we work on fluency right from the beginning with our single digits. Then we grow out to computational fluency, and eventually also procedural fluency. So procedures that aren't computation are, like comparing fractions or ratios, things like that. So with computation, I'm really zooming in on the 4 operations: addition, subtraction, multiplication, and division. And Mark just put a link to the book. Thank you, Mark. So to start out, just to be clear, fluency is this, what we're talking about tonight is computational fluency, but fluency, when we hear that word, is really broadly about being adept at using numbers. So secondly, these words, mastery, fluency, and automaticity, get tossed around synonymously, and they're really not the same thing at all. So I want to go to that one next. When we see something in our standards that says fluently subtract, it does not mean fluently use standard algorithm. It's interpreted that way, and it could be interpreted that way on state assessments, but that is not what fluently subtract means. So we're going to have a look at that. Subtract these, either one or both of these numbers, any way you like. And if you'd be willing to type in the chat, let's start with 92 minus 19. Could you type in the chat? Oh, thank you, Amy. Oh, you're ready. And Dan, thank you for playing. All right. If you would be willing to share, we're seeing several different methods. Wonderful. Let's switch to the other problem. 403 minus 299. So various methods, right? So on the first problem, I did see standard. I did not see standard I do see standard there. So I would argue that in both of these cases, that regrouping is a slower method than an invented method. Given that we have access to these strategies, if we don't know these strategies, then the standard algorithm is all we got. But for example, here, 403 minus 299, if you can just picture a number line and you can just see that space 300 to 400, and there's a little bit of, there's 1 over to 299 and a few over to 403, but it just stretches out a bit. So there's, you can almost visualize that those two numbers are 104 apart. It's hard to talk and do math. And so to actually regroup over 0 is a troubling method because it is very error prone, and a problem like this could be solved in the ways that you're sharing. So this is then the meaning of fluently subtract, is that you pull from your toolkit, right? You solve it in the way that makes sense. And when you need your standard algorithm, you pull it out. And sometimes you have a problem where you're like, I'm using my standard algorithm for this, and somebody next to you doesn't choose it. But then there are problems that really we shouldn't be using our standard algorithm for. It's just too straightforward to need a tedious algorithm. So that's really what takes us to what fluency is. Fluency is 3 components. And while I've cited my book here, these components of fluency are from the National Research Council. They've been around for a very long time. They're named in the Common Core State Standards. They're probably named in your standards. They're in our Kentucky standards. They are commonly the way that fluency is defined in research and in policy. And so what we've done is we've taken these big words and further talked about what they would look like, so that we can assess them. What are these 6 things that they look like? Well, when you see a fluent student, it's kind of like number sense. It's got all these sort of components, these characteristics. While a fluent student selects appropriate strategy, will trade it out if it's not working. They might try one thing, it doesn't work, they try something else. They think about whatever they're doing, they don't get too hung up, too bogged down in what they're doing. So this isn't about speed, but it is that they don't get stuck or bogged down. And then there's this accuracy piece over here, which is not just that they get the correct answer, but they actually know the process in the way that it's supposed to be implemented. All right. So anyway, so these are the components of fluency. So as we're doing the task tonight, just be mindful of your own actions as you do that, and how we could be nurturing those very actions in students. So to be clear, Mastery and automaticity are fine to trade out, but fluency is this bigger notion. It isn't just that you have mastered an algorithm or that you know a particular procedure. It's really that you have this ability to know when to use the strategies that you've learned and that you're flexible in how they are used. All right, the third and final fallacy is or language challenge is mixing up what a representation is and what a strategy is. And why this is important to me is one of the biggest complaints I hear from parents and from teachers and from neighbors and, is that there's just all these crazy strategies. And I'm like, what do you mean strategies? And they're like, my kid is like adding on the number line. And I'm like, that's not really a strategy. That's a way to visualize what's happening with the numbers. That's a representation. And so I think we ourselves feel overwhelmed when we don't sort of sort out the difference between a representation or strategy. So I'm going to share with you a few statements that students make in the classroom when they're adding 29 plus 13. And you're going to type in the chat whether you can put an R if you think it's a representation and S if you think it's a strategy. And the chat's going to just start flying because we have a number of people here, but that's fine because hopefully we'll see consensus. All right, so here we go. We've got add. I haven't put any student statement up yet. Okay, here student Tara says, I moved one over and added 30 plus 12. And also make sure you see attendees in your response so everyone can see your answers, not just me. Yes, this is a strategy. All right, then Oscar says, I used a number line. And we've shifted to the R's. Wonderful. I've met students like Oscar because they realize that when they say I used a number line and the teacher's like, good idea, and move on, that answer works no matter what the problem is, and they don't actually have to think of an answer. So we have to be careful when they just name a tool that we follow up and say, how did you use the number line? All right, Audrey, I looked at the hundreds chart. Representation. Devante, I added 20 and 10 to get 30 and then added 9 and then 3. Strategy. You all are so fast. Kendra, I counted up. Strategy. I pretended 30 plus 13. I pretended it was 30 plus 13 and took one away. Strategy. What a savvy group we have. I thought about base 10 blocks as sticks and dots. Awesome. All right. So we're all on the same page. The difference between a representation and a strategy. So in the school that I work in, we actually create bulletin boards for what we did before COVID. And now we're going to go back to doing that again. But to have students understand what are the tools they can use to help them reason, and then what are the ways that they might reason. So here's the tools they might use, and then here's the strategies that they might use, for example, to add. So something like this allows us to have reference and allows us to make the distinction that they could pair up base 10 blocks with compensation, or they could talk about hundreds chart and counting on, and there's not a one-to-one match at all, but they could say, I use the hundreds chart and I counted on. And what that does is that helps us help them make these critical connections. This is a visual I shared last week in the webinar about the importance of representation, which is what Braining Camp brings us, is these very interactive, versatile visuals that then help illustrate and make visible the reasoning. So we're going to be looking at virtual versions of these tools so that these visuals help students make visible what they're trying to say verbally, and then we can help translate them into the symbolic representations that go with them. And of course, we always can add a context. So a story context can always help. And if you've really attended to Math Practice 2, you know that it talks about how students can bring a context to an abstract problem, that is one way that, that we exhibit our ability to reason abstractly, is that we add a context to help us make sense of it. So that's one of our math practices. So representations are not strategies. All right, so there's lots of other questions in figuring out fluency, enough to fill a book, believe it or not. Which strategies are necessary? Which representations are necessary? Which strategies might be optional? Which representations are optional? If a student continues to, what do we do if a student continues to just count by ones? These are questions that I hear regularly. What if they're only using the make 10 strategy and they're not using compensation? Do I just let it go or I don't? Right? These are really critical dilemmas. To what extent do I require students to learn to use the strategy? How do I assess fluency? If it isn't just accuracy, how do you assess beyond accuracy? Sadly, we won't get to that tonight. I'll have to be invited back for another session, Dan. And then finally, isn't it just better to teach standard algorithms for some students? Doesn't it just make it worse when they have more stuff to remember? That's our equity question that we will come back to at the end today. So it's time for us. This was my setup to hopefully these questions will be pinging around in your mind as we start digging into tasks. So I have just a preview. We're going to do these. We're going to do these one by one, but we have several tasks we're going to explore. And this very first task, I want to explore with you across lots of different visuals, because each visual gives access to different strategies and just lends to certain strategies. So some of them are highlight one way and another tool might highlight 3 ways. So, and it's going to vary with the operation. We're going to start with 48 plus 49. So before we post the link, then what I'd like you to do is just reason in your head how you would solve 48 plus 49. You don't need to put it in the chat, but just tuck it away on a piece of paper or something so you don't forget how you would solve 48 plus 49. All right, and let's see, Ryan, we are ready for the first code.
I think Mark's putting it in the chat right now.
Perfect. All right, so I'm going to take us to what to do with this code. For now, what you need to do is copy the code. And I'm going to stop share for a moment. And I'm going to reshare. Uh-oh. All right, so now I'm sharing, we're on the Braining Camp landing page. And if you put your share code in down here, then it will take you to the first site we're going to look at for 48 plus 49. Whoops, I typed it in wrong. DC34, was that LJ?
Jennifer, would you, if you could just pause for a second, people who are watching the webinar, if you look up at the top of Jennifer's screen in her URL, those last 8 characters are the code that you can use to type that in. So if you're watching online and you're watching a recording and you don't see the chat and can't get that code, you can view them in the URL or as Jennifer types them into the box.
Yes, I've asked Mark, Ryan, Dan just to jump in whenever, because they know so in depth these features that I just feel like I know a fraction of. And this is one of the nice things that I've learned recently, is that these 10 frames can be used with the color tiles or with the 2 color counters, either one. So I have them here set up with the tiles. But I wanted to introduce this as a tool. And then I would love to, I'm getting the chat back where I can see it now that we're situated, for somebody to enter in the chat a way, so a way that you would solve this. Okay, so I see, I just saw Annalise saying, I see it as 100 minus 3. So 100 minus 3 on your board, you play with it and it doesn't change this landing board, which is a really great feature for classroom teaching, because they can start with something like this and you can ask them to create a visual of their strategy. And then, as we're going to see here in a minute, they can share what they've created and post it. So I'm just going to try to get into Annalise's head here. Okay, and Amy said the same thing, 50 plus 50. So let's start with that. A way to think about 50 plus 50 is they're sort of imagining that this frame is also full and this frame is also full. And so this is one way to show a compensation strategy. They've added this. You can easily see that you have 50 and 50, 100, 10 frames, 100, in a beautiful place value way. And also that you have these 3 pieces that you put in there that you have to compensate for in the end. So now you have 100 minus the 3. So that is one way to show this. We can take these guys back out. And then I saw 50 plus 47, 50 plus 47. So what I think that strategy might have been was taking one from here and moving it over here. And that is what I would call a make tens strategy, growing out of the basic fact, making 10 to make tens strategy. And we can see here that it's moved over and we haven't gained or lost any quantity. Beautiful. Yes, love the chat. Conversely, 2 of these, whoops, now I'm moving the whole thing. 2 of these could have moved over here, same thing. Did anyone think of it differently in a way that I could? If you did it differently, type it in the chat. Aha, 40 plus 40. All right, so then we can just group this up here. You can see I've grouped here this quantity, and this feels like a partial sums, right? We've added our tens, and then over here, what we have is a basic fact, because we've been using 10 frames with our facts additions, and this is partial sums. Beautiful, beautiful. Aha, Jessica has another way, which is she's just seeing the 45 and the 45, and then she's seeing these spares as 4 and 3, so 7 more. So we have the 90, beautiful, okay. The trial code is, the trial code, Mark, we'll have to, there you go. All right, so that's this first opportunity. So let's go to a different visual. So we see the opportunities that using 10 frames, either with tiles or you could do the same thing with 2 color counters, but it's nice to have these 4 colors here. Okay, I'm gonna go back out to apps. You can follow along, or you can just, with what, with your own work, or you can watch. And here is, coming up is the 100 chart. But you might know that I'm not very fond of this 100 chart, because I don't like saying move down 20 to go up 20. So I really like the flipped version. This is the right side. This is the this is the bottom up 100 chart. And we're going to think about this problem again with the 100 chart, bottom up. So we have 48 plus 49. I can take my text box here and just type it in so we remember what our problem is. And with students, we can even continue to notate what's happening. So one thing we could do is, actually, let me give you a moment. I'm going to stop right here, but I've just put my start number at 48. What might a student do next? They start at 48. Count on. Thank you, Jessica, for saying that, because this model lends to a counting on strategy, and it's a great beginning strategy. Okay, up by tens, add 10 at a time. All right, so we could count, and you see why the bottom up works when you see how Laura Rockwell, Laura, you got to add and attendees, said, we're going to count up. We're going up physically, we're going up quantitatively. So we could go up. And I hear somebody say we go up 40, and then we can go to the right 9. I'm adding 49. All right, that's one way we could do it. I'm trying to capture some of the ideas and how to illustrate them. Another thing I think I saw was go up 50 and come back 1. Is that what I saw? Up 50, back 1. Thank you, Kathleen. All right, I'm going to undo that. Another idea. Start with the biggest number first. Aha, let's start with the biggest number first. Let's move this over to 49 and then count in tens. All right. So I've counted by tens, and now I have the same 2 options. I could count on by ones, or I could add an extra 10 and then come back 2 now because I was 2 over. So I'm still landing at 97. So this tool, go back 1, then up 5. Aha, go back 1. I got to think about this. All right, so back 1 here. And up 5. So that is the sort of +1, -1. Beautiful, beautiful. All good methods. Also, we could, for students who already have lots of work with the standard algorithm, they may want to deal with the ones digit first. And so what that would look like is we can still, let's go back over here and start with 48. And then they're going to count on by ones, perhaps. There's 9, and then go up 40. It's a beautiful illustration for how definitely adding the ones and then adding the tens works, but it's just a lot of steps counting by the ones. Yeah, it's beautiful. And what happens is this particular visual really helps students see that adding 9 is the same as adding 10 and subtracting 1. And that's a very useful strategy. It's very useful, not just for addition, but in lots of situations. I've read some studies that students who recognize that 9 is 1 less than 10, that 7 is 1 more than 6, that relational piece in kindergarten, it predicts their success through 3rd grade in general math achievement, not just fluency. So this model really plays to that. All right, the next thing we're going to go to, Mark, if you can put in the chat, is the base 10 block setup to explore 48 plus 49. And if I missed your strategy, I apologize, but you can see how beautiful students can do this, enacting themselves and share you a picture. It gives you insights into their thinking, what strategies they're using, and it really elicits this number relation piece. All right, so then if you're going back out to get to this little setup I have, this was just, this is a time saver, so you don't have to watch me set this up. And here we are, 48 plus 49, your landing page. What I would like for you to do is remember back to how you thought about 48 plus 49 before we came to Braining Camp, and then think about how you could show your thinking with the base 10 pieces. So I'm going to be quiet for about 2 minutes and give you some time to build your problem. That probably wasn't close to enough time. So if you are still building, please do. But we have set up a folder of tasks. Oh, not for this one. Forget it. I never said that. So what Jessica and Bryn are doing is fantastic. So I'm going to pull out a few of these that are showing up early. Keep working. And I assume if you're typing it in the chat, then you're giving us an opportunity to see your thinking. Beautiful. Okay, I'm seeing some love for Bryn, so we're all curious. Sadly, we don't have hours to look at everybody's work. But as I started to say earlier, because we're doing this with the next task, students can paste them into like a Google Doc, and then you really can see all of them. Oh, this is the same one. Beautiful. I'm not sure why I continue to type in the different codes and get the same work. Really not sure why that's happening. All right. Well, we're going to move on, but you can see the many different ways to show this. And when I was first exploring this website, I'm going to erase some of this. I was wondering about the idea of 50 plus 50. And I discovered this kind of cool thing. So I hate to erase this work, but I don't know why it keeps showing up, even though I'm trying to share lots of people's work. So Mark or Ryan, if you know what I am not doing, please let me know. But one thing we can do here as we build it, here's our 40 over here, is if I'm thinking about this problem, I'm thinking, you know what, I really don't want to drag down 8 of those yellow buttons or cubes, ones. It's been a long day. So I'm just going to go ahead and pull this one down. But I already know that 2 of those are, I'm not going to think about. I know I've got too many. So I'm just going to kind of mark them. And then I go over to the other number, 49. And in the same way, I can bring down 4, and then bring down 1 extra. But I got to just remember that there's 1 here that I really have to remember to compensate for later. And what you can do is when you group these and you have enough, it allows you to regroup them so you can really see the 100. Of course, you just lost my black dots, but I remember I have 3 I need to take away, or I could break it back apart and put them back there. And this little guy needs moved. Well, you get the point. All right. If you have any comments about 48 plus 49 or any of the visuals you've seen so far, please enter it in the chat. But we are going to go to our final visual for 48 plus 49, which is the open number line. Certainly one of the most important tools that we can use to help students reason, but also notice we have tinkered around with some other things that are very area oriented or length oriented before we get to the number line so that we can build that. And quiz and air rods. And Annalise, thank you for bringing that up. So I'm just going to go out to apps, and then I'm going to select the number line and come back in. So hopefully you'll join me. And down here where it says basic, you just opt for open. And now we have this opportunity to show different ways of thinking. So I can have several lines to show different people's thinking. And I'm looking at the time thinking, oh my goodness, I can't show all the ways. But earlier when we were with the looking at the 10 frames, we saw lots of different thinking. And that can all be illustrated here by showing the jumps of 10 and beyond to illustrate the way that students are thinking about the problem. So I am going to walk away from this right now and go on to the next task. All right. I want to switch to fractions just to do some work with fractions. We're not as flexible with fractions as we could be for sure. And then I also wanted to switch to subtraction. So we're doing the double move. We're moving operations and we're moving number type. So it's going to get, a little bit more challenging, and we need the code for fractions. We're on to 7 and 1/4 minus 5 and 3/4. Go back out. And what I would like for you to do is go ahead and illustrate your solution to this. And Mark is about to type in a Google document, a Google folder. When you get to that folder, if you can see, hopefully you can see my screen, you have all these tasks. And when you open up these tasks, this is where we're at. We're at task 2, the fraction problem. You're just going to save. I'll show you how to save, and you're just going to paste your work in here. And this will give us, hopefully, if many of you do, all of you don't need to, but it will be able to see sort of what common strategies are. In a classroom of 25 students, you can start to see what is common thinking, and that gives you some really good formative assessment data. So that's the link. Thank you very much. And I'm going to go back to my number line. Not that one. Yes, this one. When you have this finished, you simply go over here to share and copy your image. That's how you do it. It comes from over here. Kathleen, if you have a chance, could you, if maybe you've already done it, instead of using the code, could you paste it into the task Google Doc? All right, we have some, I'm gonna I'm gonna take a look at this. We're in the Google Doc, so you can see how beautiful these sketches look from our students. And you can definitely continue to add them. So here we see some strategies where, similar strategies where we're using a takeaway interpretation of the problem. In this case, taking away to get to a whole number, then taking away a big chunk of whole numbers, and then the remaining fractional part. This is taking away the whole number first and then some parts. Again, taking away the whole and then the fractional part. So we can see, oh, we have a different one here. I'll come back to that. Here's another takeaway, but the fractional part was split up so that you could go from a whole number to a whole number. So as a teacher, I'm thinking, yep, I'm seeing this, this is great. Lots of takeaway strategies. Let's go back up to this one. This one looks completely different. What is going on here? So now I've got one I want to talk about, and we can make sense of this strategy. What is going on with this method? Yeah, there's some adjusting and comparison. Thank you. Ryan and Jessica both jumped in here. I appreciate your thinking about this, because some people are still working on their sketches and I'm looking at the time and I know I'm overplanned. But notice here, first of all, the person who came to this problem, rather than thinking about taking away 5 3/4, just decided to find out how far apart those two values were, a compare interpretation. This is really important. Notice how many of us are in a takeaway mindset as we scroll down through here. And I've done this with this exact computation problem. Oh, here's some more compare coming down here. But it is always more common for us to think takeaway. We grew up in a school system in which we did takeaway, 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 takeaway. Finally, Common Core brings up the importance of thinking of subtraction as compare, but it's only really mentioned in second grade with whole numbers. And so we get to fractions and our takeaway takes over. So we have to remember compare as an option, and that's a fluency thing, because here you can see how much you have to take away to get to the answer. Whereas with the compare, I'm going to scoot down to one of these other compare ones. You see, it's just a jump of 1 and then a jump of 1/2 to get from 5 3/4 to 7 1/4. So that is a shorter thing. And then this method actually also, besides thinking compare, also thought, you know what, I don't even like those numbers. I'm just going to picture these two values and do the shift on the number line, which I really appreciate whoever did this, because you're going to help me speed up the next task I wanted to work on with you all. Here's what I would like for you to do. Is there are three tasks. Actually, I'm looking at the time, and I think I'm just going to skip the you pick. But in the folder here, I was going to have you just pick one of these problems, 3, A, B, C, or D, to just think about what visuals will work. So they're there for you, and you can do this activity with your students. It's pretty, the Google slides are set up pretty easy to use. So I'm going to skip that, however, because I want to move on to coming back to how these different visuals give us different insights and how important the number line is. But I want to switch to, while we're on subtraction, this notion of compensation. So I'm going to stop share for a moment. actually, I'm just going to switch over to this problem here. If we have 74 minus 49, and I'm switching gears now, I'm saying, we're not just, how would you think about this? I want students to know how to compensate. So that question about which ones do students have to know and which ones might they know? For me, compensation is on the must-know list. It's on the must-know list because it's so useful for being able to efficiently get to answers many times over. Certainly with 2-digit minus 2-digit, 2-digit plus 2-digit, it's a very important strategy. And what happens is students are very good at the make tens strategy, moving one over. So when they start thinking about how they could adapt 74 minus 49, they want to apply an addition idea to the subtraction. So let's just, I'm going to do something here. You're going to pretend you're not looking at this page. I'm going to put the shapes up here. And I'm bringing my little shape over. I'm going to hide my little strategy here and just fill that in so that it's not distracting us right now. So for 74 minus 49, there's 3 different ways I could go about doing compensation. One way is I could just change the first number. And a convenient way to change the first number could be to just change it to 79. So then I end up with 79 minus 49. In this case, the student notices that they put 5 extra in to the problem. And this could be shown with counters on any one of these visuals. I could also, I'm going to have to compensate by taking 5 out. So that's one option. Another option is that they could instead change the subtrahend. This is where it gets tricky. They've now taken 4 away, taken 5 away, but they've taken 5 away from what's getting taken away. So for this particular problem, I'm not even on the Braining Camp place I need to be on. I need to be back over with the counters. But can you see that we're taking away less than we need to take away? So what's going to happen is we're going to have to take away even more. And then the third way to compensate is to actually change both of them, which we saw beautifully solved with the person who did the subtraction with the compensation. And this is what it could look like for this problem, is that instead of thinking of 49 minus 74, they just scoot. This one can scoot over 1 and this one can scoot over 1. The distance remains 25. So as we scoot it, we're adjusting and compensating side by side because we're looking at a constant distance, a constant length. So we have lots of ways we can compensate. And the key is that students understand what happens when they change the first number. How did they change the problem? They put more in the quantity. That means to compensate, they've got to take more out. If they change the subtrahend one way, then they have to think, what did I do to the quantity in the problem so that I can later compensate? And then that's what happens here with the compare interpretation, as well as thinking, as I move one this way, the other one moves this way. Move one this way, the other one moves this way. They got to keep that constant difference. All right, so I'm going to stop sharing that. And I am going to go back to my PowerPoint. Because our time is just flying by. All right. So in review, we looked at 48 plus 49. We saw the way different visuals give you different insights to strategy. So if you're really trying to teach a strategy like compensation, then pick a visual that's going to help them see how compensation works. And then we looked at the subtraction and the beauty of the number line. of being able to show both takeaway and compare. Eventually, when you're working with fluency, you want students to be able to look at a problem and think, I'm going to find the difference here. Those numbers are close together. I'm going to find the difference. And other times the subtrahend is relatively small. I'm going to do takeaway here because that's going to be easier because of the size of the numbers in the problem. Then we skipped doing these, and you can just see from looking at them, there's lots of different visuals and ways that you could solve them. And then we skipped multiplication, and there's strategies for multiplication as well. But I'd like to come back to the significant strategies and these questions that we left off with a half an hour, 40 minutes ago. These were the tasks, some of which we did, but these are computation problems, and they're not hard to find, although I have found anytime I try to Google a worksheet or Google problems, there's all sorts of wonky problems that are not commonly encountered in real life. And if we could just stick with our common fractions and our common decimals, that's when we need our fluency. That's when we can use our mental arithmetic. And if we could do more with that, our students would be better off for the life needs they have for math. So what are the significant strategies? Count on or count back. We saw that on the hundreds chart, and we saw that on the number line. Make tens or make a whole. We saw that with 10 frames. You can also do it on the number line. You can sort of see it on the 100 chart, but to me, make tens or make a whole fits with the base 10 blocks. Annalise is about to type into the chat quiz and error odds. I know you are. And the 10 frames, of course. Break apart to multiply, we didn't get to work on, but the area model is just beautiful for that. And Mark, you could go ahead and put the link to the area problem that we had set up so they have access to that setup for the 15 times 12. The key with 15 times 12 is not saying, oh, it's going to be a 2x2 grid and we're going to separate it into its tens and ones. That's too algorithmic. You could split either one of these, and the minute you can split one of them and you can solve the problem mentally, you're done. You don't have to split both of them. And there's lots of ways that you can break them apart and form a combination. You can break them apart by add-ins. You can break them apart by factors. So we just don't have time. And we could have and double. Double this number, have this number is another strategy we could use. Have and double here would work beautiful. So have and double is a special case, but it's a super useful one, especially with tips at 15%. You can have and double. Partials work across all the operations. Compensation is just a beautifully useful, very flexible strategy. And finally, use the inverse is a strategy for addition, is a good strategy for subtraction and division to operations for which there are not that many strategies. So here's some important takeaways for me about fluency. It is about students choosing strategies, but they first need to learn to use a strategy. They need the visuals. You can add context as well, but they need to be able to make sense of why the new expression is equivalent and to see how flexible it can be, that they could go this way or they could go that way. They could jump over the number and come back again. And it's visuals that give them that flexibility. So they first need a lot of experience to use the strategies. And then that's not good enough. If we just move on to the next strategy, we wonder why they see 48 plus 49 and they start like thinking, oh, what am I supposed to do? What does the teacher want me to do? We have to teach them to choose strategies. And that's what we really focus on in the book is first, how do you use them? How do you use visuals to get them down? And then lots of games and lots of routines where they're in a position to choose them. So what does that look like? Well, as you're teaching a strategy, I showed this last week, but I've changed up what's in the blue boxes. You teach them with the visuals. You teach the strategies, you practice the strategies, and then you assess all components of fluency. And then once they've got, it's additive, right? They know 2, 3, 4 strategies. After they've learned the standard algorithm, they're in particular, I'm going to call them at risk of overusing the standard algorithm. So being able to practice using those reasoning mental strategies. Mental strategies are always quicker than written strategies. So this is not fluency, no. What fluency is being able to visualize and use these strategies. So all of these tools we looked at tonight. Well, we didn't get to a Cuisinart Rising, Elise, I'm sorry about that. And then also sketches. Students' own sketches are really important in the process to develop these strategies. And that's how we really make sure that we address, I hope I've addressed these questions, but it's through those visuals that we address these questions. And I think I've addressed which strategies are necessary. The representations kind of depend on which strategy you're working on. And then I want to finish with talking about question number 8 here. Isn't it just better to teach standard algorithms for some students? I feel so sad when I get asked this question. It is true that students with special needs and students who struggle do not need one more thing to memorize. They don't need to memorize at all. It's a very weak learning strategy, but they do need access to efficient reasoning methods for solving problems. Otherwise, they're even further behind because it's taking them so long to apply a standard algorithm in a case where it's not even appropriate. So it is certainly an equity issue. I want to go back to this point about equity with this notion right here of efficiency. Efficiency isn't about how fast you are. That really plays to many students' anxieties and weaknesses. Efficiency is about making a good choice about the strategy that you're using. And as students learn to choose the strategy, their efficacy goes up, their identity shapes, they realize that they can figure out that they get to choose how they're going to solve that problem, but they have to have their mind on what's efficient. It's not anything goes. They need a good method to solve that problem. And that's what real fluency is. And so this is just a quote I want to end on. These competencies that when they choose, they develop this strategic competence and adaptive reasoning. You may recall that comes from the definition of procedural procedural fluency, of proficiency, of mathematical proficiency from the National Research Council. These competencies positively shape students' math identities and then gives them that sense of agency. So fluency efforts have to ensure that every child has access to a range of strategies and have regular opportunities to choose among them. This is the book that these ideas are in. I'm so grateful to Ryan, Mark, and Dan for inviting me to talk about fluency, and so grateful for the visual tools that have been available to so many of us during COVID and going forward to help make strategies and thinking visible. Thank you.
Well, thank you, Jennifer. Thank you for, I know you didn't get to as much as you wanted to, but I'm still going to hold to my statement earlier on of amazing. And I hope the panel, the attendees see that I wasn't just speaking in hyperbole. So thank you so much for all that for tonight. Ryan, did you have something that you wanted to say?
No, I was same. Thank you, Jennifer, for everything you've done and sharing with us these ways to think about how students think and how they can think. I'm checking out the chat and seeing how many people are saying similar things and saying that thank you. It's amazing. It's wonderful. And I think you have proven that we need to have you back another time here soon. So I'll just leave it at that.
Thank you.
Somebody asked,
somebody asked about the slides, uploading them into the Google Drive. I will do that. I'll put a PDF up there.
That is another thing too. This webinar has been recorded and we will be putting it up on our site, hopefully in the next 24 hours or so. But if you go to Branding Camp, you might even look on your page at the top where it says webinars. You can click on that and you will see upcoming webinars. But if you scroll down, you will see links to all of our previous ones. So if you missed Jennifer last week, you can see the one from last week and you can go back and see others going back through sometime last year.
All right, Dan. Dan, anything you want to say before we go?
Same thing. I think all of us are just so grateful and appreciative to have you here. We know that there's a lifetime of learning that goes into so much of this. So to be able to distill it down for us so that we could learn so much in an hour is a real privilege, and we're incredibly grateful to you, Jennifer, and we can't wait to have you back.
Yeah,
You're
just go with
muted,
that.
Jennifer.
Thanks you all. I really appreciate it.